Hello everyone. Today we discuss about internal resistance of a cell and relation between internal resistance EMF and terminal potential difference of a cell. First we will discuss about the internal resistance of a cell. First we will know what is internal resistance. When the terminals of a cell are connected by a wire and electric current flows in the wire from positive terminal of the cell towards the negative terminal, but inside the electrolyte of the cell the positive ions flows from the lower to the higher potential or negative ions from the higher to lower potential against the background of other ions and neutral atoms of the electrolyte. So the electrolyte offers some resistance to the flow of current inside the cell. Some resistance actually. So what is internal resistance of a cell? The resistance offered by the electrolyte of a cell to the flow of current between its electrodes is called internal resistance of a cell, or you can say also the opposition offered by the electrolyte of the cell to the flow of electric current through it is called internal resistance of a cell. Now this internal resistance of a cell depends on some following factors. Number 1, the nature of the electrolyte. Number 2, it is directly proportional to the concentration of the electrolyte, and it is directly proportional to the distance between two electrodes, and it varies inversely as the common area of the electrodes immersed in the electrolyte. And number 5, it increases with the decrease in temperature of the electrolyte. Actually, the internal resistance of a freshly prepared cell is usually low, but its value increases as we draw more and more current from it. Okay, so now we discuss about the relation between internal resistance, EMF, and terminal potential difference of a cell. So first we will know about what is terminal potential difference. Okay, listen. Terminal potential difference is actually the potential drop across the terminal of a cell when a current is being drawn from it is called terminal potential difference, that is denoted by capital V. Now we'll know about the relation between the small r means the internal resistance of a cell and EMF means capital E and the terminal voltage capital V. Look, this is the circuit, and let us consider a cell of EMF E and internal resistances are connected to an external resistance R, that as shown in the figure. Suppose the constant current I flows through this circuit. So actually from this circuit we know that by the definition of EMF we know the E equals to work done by the cell in carrying a unit charge along the closed circuit. So it will be the work done in carrying a unit charge from A to this direction to unit charge along the closed circuit. So it will be E equals to V plus small v. Here capital V is actually according to Ohm's law I into R, the terminal potential difference, that is also V. So V will be here I into R, and here small v will be I into small r. So this is also known as waste voltage also. So E will be I capital R plus I small r. If we take common I, then we can write I into R plus R. So from this equation we can find the current flow through the circuit. So I will be E by R plus R. This is the actual relation is called circuit equation, or you can also say the relation between internal resistance, EMF, and terminal potential difference of a cell. This is the relation. Now we discuss about, look, so if I want to find the internal resistance of a cell, then E equals to, you know that capital V plus small v. So capital V is capital I into R, and small v is I into small r. Small r is the internal resistance of a cell. So if we divided this thing by IR, then IR by IR equals to E minus V by V. So from this equation we can write R equals to E by V minus 1 into R. So from this equation we can find the potential internal resistance of a cell. So what is actually how to calculate the internal resistance of a cell by using a voltmeter method? Look, this is a circuit diagram, and here the resistance box RB, and here key is K, and this EMF E is connected in the circuit, and here the potential to measure the potential difference across E we connected a voltmeter V. Now when the circuit is open, when key is open, then no current flow through the circuit, so that means the voltmeter reading will be the EMF of the cell. When the key connected, then we'll get the actual value. Look, if the key is connected, then we'll get the actually V means the potential difference that is measured. So if we want calculate, first we will calculate the value of E by using this voltmeter, and by using the second circuit when we key is closed, then we will find the value of capital V. So by using this formula R equals to E by V minus 1 into R, then we can find the value of small r means internal resistance. Okay, thank you.